70% of the surface of this planet is covered by water. India has a meager 4%. It means that India has a 16% share of the world's population, but hardly any share of the world's water sources. India is dealing with severe water scarcity. The World Bank estimates that about 114 million Indians will soon face desperate domestic, agricultural and industrial water shortage. It's one of the largest crises facing India in terms of spread and severity, affecting 1 in every 3 Indians. I'm Manvi Dhillon and you're watching DuPont Presents The Power of Shunya, Quest for Zero. And today we're on a quest for zero water shortage. We'll examine India's water challenge from a few different perspectives to first determine how we can save the scarce water resources we have, and second, to see how we can adapt our farming techniques to cope with the reality of depleting water resources. For deeper insight into the causes and consequences of the water crisis in India, let's speak to Professor Krishna Achyuta Rao of IIT Delhi, a man who's observed the changing hydrological cycle in India for years. He understands water in the Indian context truly and deeply. Professor Rao, thank you very much for joining us.
Thank you.
In simple terms, how acute is the water shortage in India today?
I think it's a regional problem in terms of there are some places which are probably doing fine. There are some places which are clearly under some stress, I would say, and there are problems that are looming.
I'm going to ask yet another simplistic question. If you had to categorize the causes for the stress in water, in pockets of India, what are the primary causes that come to your mind?
One of the key things, of course, is the vagaries of weather, the climate as it varies, both naturally and more recently due to man-made climate change. But beyond that, there are also issues with overexploitation of water resources, poor management practices, a lot of pollution, a lot of just degradation of the kind of available resources.
What are the policies and measures in place today in India that really are thinking about our water crisis, that are addressing our water crisis?
This is going to have to be addressed, and whether it's through conservation, which is trying to make more efficient use of the water and therefore use less of it, or through managing it better, because a lot of water is just wasted and misused.
Conservation is a huge part of the approach, but the other part, and I just wanted your thoughts on that, is adapting to the realities of water shortage, rethinking our assumptions on water availability. Do you think there's enough emphasis on the latter?
There are people who are aware that you will need crops that will be resilient to different temperatures or different availability of water or different quality of water, and whether you'll have to make do with sort of brackish water. So there are people working on developing new sorts of crops that would thrive in these conditions.
Summer in India means unrelenting heat. Long queues for water tankers as temperatures soar. That's a common sight across many of our cities. Our groundwater levels are falling every month. This despite the fact that many parts of India receive good rainfall. So what's the solution? Well, if you were to ask Ayappa Masagi's Water Literacy Foundation, they tell us we all know the answer to the problem. In fact, Ayappa Masagi, known as the water warrior, is credited with returning to the fundamentals of water conservation. And he's influencing agriculture, industries, private homes, and many more. Let's see how. Less than 3% of the world's water is fresh. The rest is seawater. 2.5% of that 3% is frozen. The entire humanity is dependent on 0.5% of fresh water. Majority of that fresh water is stored in underground aquifers, but our growing demands and low rainfall are running these water mines dry. This caused a stream of water troubles for companies like Karnataka Antibiotics and Pharmaceuticals Limited in Bangalore until they employed the help of Ayappa Masagi.
We require a lot of water for our processes, maybe to the extent of about 1 lakh of liter a day. So, in fact, initially we source this particular water through bore wells. Due to the increased industrial activity over this area, the bore well started slowly getting dry. So, in fact, we were forced to buy water from outside through tankers, etc.
What's changed in terms of functioning, in terms of access to water?
As against the normal availability of water at the depth of say 600, 700 feet, we could see water at about 169, 170 feet. Second thing is, of course, our sourcing of water from outside tankers are reduced by and large. And we are able to use our own borewell waters for our production purposes and various other needs. So that's the change we are seeing post Mr. Masagi's involvement in our rainwater harvesting.
What makes Masagi's approach unique is the fact that unlike current rainwater harvesting techniques that concentrate on collection and storage, his methods recharge the groundwater first with filtered rainwater, equipping us with a system for zero water shortage. One rainwater harvesting system is under construction here at Karnataka Antibiotics.
Yes, ma'am.
What is the model that you're applying here? What are you doing here?
Yeah, here some type of religion you have 3 components. One is collection.
Okay, so is the collection happening
Yeah,
there?
collection there actually coming from the drainage. We have trapped all 4-5 acres of runoff, even roof rainwater, road water, all water actually collecting in that is called pre-silt up tank. 50% of the sediments will settle in the tank.
Okay.
Then 60-50% filter water coming and collecting. This will look like sump, no? Is collecting.
Yeah.
Here also actually started percolating and sedimenting. Start sediment. Then you have another third stage. This is called actually gallery type filtration unit, or you call it the gallery. So this gallery made up of stones, bare stones. See here, no cements, jelly, sand, pebbles they are using. All the water, that 50-60% filter water pass through. Then again coming here, this system is called storage point.
Okay.
Here bore is the storage point. The tube is connected surface to your groundwater aquifers.
Okay.
So here again the last 6th stage, we are going to make a holes and casing.
Okay.
Over that we are going to put a 4 to 5 layers of plastic netlon.
Right.
Then forest for motor I am going to inject into the ground through this casing.
You're a mechanical engineer, so explain the science behind what you're doing here.
Yeah, actually the science I'm using here, actually I'm charging all the 4 water. I have a total of 4 waters. Subsurface water, subsoil water, deep soil water, groundwater.
And these methods are yielding huge returns for farmers like Murugappa, who depend on bore wells for irrigating their crop. When the groundwater dried up, Murugappa invested in Masagi's lake-type bore well recharging method.
I found a huge catchment area, and all the catchment areas runoff actually passing through his besides his land. Then I decided to construct a lake. Here actually the lake is very huge catchment. If you harvest the total catchment area, if you harvest 5%, to harvest I designed for only 5% water for runoff. So 60 meter by 40 meter, then I go 5 4-meter depth. Then immediately agree. Then I constructed a lake. Once the lake full, actually nearby the lake, one bore was there, actually existing borewell. There we done actually H-type borewell recharge. One system called H-type borewell recharge. Totally 6, 7, 8 feet no one rises. All the water directly, instead of going into the drainage or somewhere else, it is going into borewells, directly injecting into the aquifers now. In my experience already, so 1 kilometer up to 3 kilometer. 3 kilometer radius already charged actually after 1 year or 2 years.
Murugappa is now a happy man. Within 3 months of getting the work done, he can already see the results.
ಸರ್ ಖಂಡಿತ ಉಳಿಸ್ಬೋದು. ಆಗ ನಮಗೆ ನೀರಿಲ್ಲ ಸಮಯದಲ್ಲಿ ಟ್ಯಾಂಕರಲ್ಲಿ ಒಂದು ಟ್ಯಾಂಕರ್ ನೀರಿಗೆ 500 ರಿಂದ 600 ರೂಪಾಯಿ ತಗೊಳ್ತಾರೆ. ಅದರಲ್ಲಿ 3,500 ರಿಂದ 4,000 ಲೀಟರ್ ನೀರು ಬರುತ್ತೆ. ಈಗ ನಮಗೆ ನಮ್ಮ ಬೋರಲ್ಲೇನೆ 1 ಅವರ್ಗೆ ಅಷ್ಟು ನೀರು ಬರುತ್ತಲ್ಲ, ಖಂಡಿತ ಉಳಿಸ್ಬೋದು ಸರ್, ಏನು ತೊಂದರೆ ಇಲ್ಲ.
ಎಷ್ಟು ದುಡ್ಡು ಉಳಿಸಿದ್ದೀರಾ ಅಂತ ನಿಮ್ಗೆ ಅನ್ಸುತ್ತೆ ಇಲ್ಲಿವರೆಗೂ?
ಸರ್ ಇಲ್ಲಿವರೆಗೂ ಅಂದರೆ ಸುಮಾರು ಒಂದು 2 ಲಕ್ಷ ರೂಪಾಯಿ ಆಗುತ್ತೆ ಸರ್ ನೀರಿಗೆ ತಿಂಗಳಿಗೆ.
2 ಲಕ್ಷ ರೂಪಾಯಿ ತನಕ ದುಡ್ಡು
ದುಡ್ಡಿಗೆ ಉಳಿಸಿದ್ದೀವಿ ಅಂತ ಅನಿಸುತ್ತೆ ಸರ್ ನಮ್ಮ ಪ್ರಕಾರ.
Dubbed as the groundwater hunter, Masagi has successfully implemented most of his methods at more than 5,000 locations, taking us one step closer to zero water shortage with each raindrop. While our first innovation helps farmers overcome the unpredictability of water resources, our next technology shows how by adopting a new approach to farming, groups of farmers can adapt to changing water levels in a region. Stay tuned.